Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Salam sejahtera, selamat tengah hari. Hari ini kita bersama lagi untuk siri yang ketiga, Sembang Santai bersama dengan UTM Center for Engineering Education. Saya perkenalkan diri saya dahulu. Saya Noraini Ibrahim dari Faculty of Computing, Universiti Teknologi Malaysia. Okey, pada hari ini kita ada seorang speaker yang akan berkongsi sedikit perkongsian beliau mengenai mathematical thinking practice in engineering education. Mungkin kita boleh jemput Dr. Norma masuk ke stage. Okey, so Assalamualaikum warahmatullahi wabarakatuh Dr. Norma. Selamat datang. Okey, sihat Doktor?
Sihat.
Okey, seperti yang kita Alhamdulillah. Okey. Okay, semoga perkongsian kita pada hari ini dapat memberikan sedikit pendedahan at least. Okay. Saya to be frank, okay. Actually saya memang berharap saya mendapat sesuatu ilmu yang barulah di dalam topik kita hari ini, mathematical thinking practice in engineering education. Mungkin secara umumnya saya pernah terlibat dalam engineering education sebelum ini, okay, tetapi nak zoom into the mathematical thinking practice ini, okay, jadinya saya akan perkenalkan dulu Dr. Norma. Mungkin tim kita di belakang boleh upkan saya punya ni. Okay, so Dr. Norma saya perkenalkan siapa sebenarnya speaker kita pada hari ini. So Associate Professor Dr. Norma, okay, received her PhD in Industrial Computing Supercomputer at Universiti Kebangsaan Malaysia. So kalau tengok sebenarnya CV Dr. Norma ni memanglah beliau adalah seorang yang pakar di dalam mathematical, okay, bidang mathematics. So kita boleh kata speaker kita pada hari ini memang terlibat, okay, di dalam big data analytics on high performance computing, okay, validation of complex mathematical model, solving grand challenge application in nanotechnology, IoT, AI, smart digital towards industry 5.0. Okay, this is very interesting. Okay, kalau tengok research profile Dr. Norma pula, okay, saya boleh zoom lah sebenarnya. Saya sangat tertarik sebenarnya dengan Padlet Dr. Norma ni sebab semua maklumat ada very informative dan accessible. Okay, so kalau tengok bidang expert ataupun expertise Dr. Norma memang di dalam big data modeling and simulation, especially in AI, okay, BDA atau big data analytics, okay, mathematical modeling of complex system. Ini yang kita nak perah lah, maksudnya perah maklumat, okay, menyerap maklumat perkongsian daripada kita punya speaker hari ini Dr. Norma, okay, untuk memberikan sedikit pencerahan sebenarnya apakah sebenarnya yang diperlukan, okay, di dalam membangunkan personality ataupun kita boleh kata knowledgeable person lah di dalam mathematical thinking ni dan apa aplikasinya. Okay, so saya rasa itu saja. Mungkin Dr. Norma nanti boleh sharekan lagi lah kalau saya tidak menyentuh mana-mana aspek mengenai bukan peribadi sahaja, kepakaran Dr. Norma, okay, supaya kita boleh bring audience kita pada hari ini untuk embrace sebenarnya macam mana kita nak leveragekan, macam mana kita nak enrichkan mathematical thinking practice ni di dalam engineering education. Okay, Dr. Norma, all yours.
Assalamualaikum warahmatullahi wabarakatuh. Thank you to moderator Dr. Noraini Ibrahim, former research fellow, Center of Engineering Education, Universiti Teknologi Malaysia, senior lecturer, School of Computing, Faculty of Engineering. So in the series 3 Sembang Santai, okay, Center of Engineering Education, I would like to share, okay, some knowledge on mathematical thinking practice in engineering education. I know I'm not the expert. Even though engineering education, example, Dr. Yudaria, practice mathematical thinking in teaching, learning and research, right? So this is my angle based on my expert, okay, in my research area, especially big data and high performance computing. Okay, I think I'm sharing my content Nampak ke moderator? Ada
Boleh. Boleh nampak.
Content. The content is what is mathematical thinking actually? How to explore mathematical thinking in engineering education. And what is mathematical thinking in university level, and the interaction, because you are engineering, so means that the computational thinking and programming is very important when you do teaching, learning and research, right? So mathematical thinking tool, hardware and software for education, and the early path of roadmap for scientists, and the tips to improve the mathematical thinking ability in engineering, education, and software. All right, and then some conclusion. Okay, now I love if we can vote. Okay, this mentimeter.com. Okay, because this voting just to give you awareness about mathematical thinking. All right, because I know most of thinking that you practice a lot. So based on this questionnaire, we can learn, we can share something new. All right. So I give you a few seconds. I'm also right at the top chat. Okay. And you can vote what is your understanding about mathematical thinking. Right. So now I just want to address here a common types of the thinking. Okay, even though we are teaching, okay, and learning online, okay, dealing with the student for doing research and others, so we practice the creative thinking, analytical thinking. We have a lot of way to do the analysis. All right, critical thinking is very important, and concrete knowledge using the axiom, postulate, formula, and theory, and diverge thinking or converge thinking. All right. So in numerical, okay, we always find the converge. Okay. Solution. So now let's we go to the motivation of thinking. Okay. We know that thinking is active of using brain and considering a problem and create a new idea, all right, a new solution. So how you structured the new knowledge, right? This is a time of the make a decision and quick thinking, okay, conceptual framework especially, right? Creative thinking including analysis, open mind, problem solving, how to organize and how to do the communication, right? Critical thinking is the analysis of available facts, evidence, observe, ideal form, a judgment, and this is a subject with a complex, okay, with a several analysis, right? In mathematics, there are so many ways to do the problem solving and to do the analysis based on the different numbers of performance indicator. All right. So now, this is the way, this is the motivation of thinking engineering education. Okay. There are expert thinking, okay, improving the productivity and efficiency, effectiveness. All right. Produce thinking is about achieving completions and momentum, and coaching thinking is cultivating people and potential. However, for the big picture creative ideas. So they start do the innovation. All right. What a few groups, mathematical thinking in UTM, they start using mathematical thinking to do the innovation. Planner thinking is about design, effective system, and energizer thinking is about mobility, build a strength of the relationship. So you are engineering education. I know this is a common practice. Okay, you apply in teaching research. Yes, moderator, can I answer this question?
Yes, actually I wish to ask you the same questions. Okay,
Uh-huh.
so sebenarnya how actually uh, you use or you relate the mathematical thinking to develop the knowledge, the specific knowledge on the mathematics. Yeah.
Okay. So yes, yes. Because before we go for engineering education, we make the relationship between mathematical
Mm-mm.
thinking ASIUM, okay, and mathematics, okay, create the thinking itself.
Yes.
All right. So
Mm-mm.
now I love it if I can share the history. History
Mm.
8,000 before century era,
8,000.
5,000 before 8,000, and then 5,000 before century before century era,
Mm.
3,600, and then it's 1,900 and the present day. So we go to the journey. All right. Okay, from the Cans Darwin, all right, they said that okay, the number or arithmetics as it's 8,000 before century to Greek geometry, trigonometry before 500 century era, right? And then, okay, based on the Greek mathematics, okay, 300 century era, okay, they go to the new, okay, paradigm, right? 1,600 ago, where we start appreciate data, all right? When we have a data, so we start do the theory of statistics, theory, right? The 1900s, okay, years before, and this is they create that mathematics is solving a dynamic system. Solve the 2000 okay years here. Okay, people looking for data and they do the data analysis or data scientist, all right, or data okay, big data simulation or big data analytics. Okay, so this is a journey where the people thinking actually, okay, there are so many definitions, but the latest, okay, based on the fourth industrial revolution, I can say that, okay, mathematical thinking is a way to solve a problem step by step, maintaining confidence in your work as you take steps forward. All right. So they make the new knowledge, okay, explaining a new knowledge in structured technical thinking in engineering education. I can list okay, the challenge engineering education, especially to highlight the mathematical thinking is a learning to model in engineering. I know you have so many research, okay, but to bring a new knowledge thinking level at the university level, how to model it, how to prove it, how to transform in the mathematical notation, for example. Okay, incorporating mathematical modeling into mathematics education. This one interest and researchers and mathematics support engineering. So there's so many phenomena: pressure, temperature, dynamic, okay, fluid dynamic. So how we want to explain in mathematics in logic theory. All right. Example: we use finite differential equation when dealing with the advanced circuits analysis. We are using electromagnetics, okay, as a basic physics and mathematics. In mechanical engineering, okay, of course, the in the ASIUM, in the postulate and others. Okay, how to integrate mathematical thinking and engineering. Okay, engineering thinking for creative and innovative. And what is a tool to visualize the thinking in engineering to graduate engineers who can design a complex thinking is become challenged nowadays. All right. So now let's we look, okay, the physical that we have. We have left brain, right brain. We know the function
Yes. Mm-mm.
of left and right brain, all right? And the left helps us to compare and roughly estimate, all right, the solution, the exact solutions and others. Okay. This is you to join this Padlet, okay, where you can ask me a question. I give a link at the top chat, or you can go to the top chat and write the question, right? If this link is the Facebook, you can write at the Facebook, all right? So we answer there, right? Don't forget to click button, share the question here. Okay, I am trying to answer the question, right? So now, since we are university level, okay, so we'll always use Scopus and Web of Science to refer. Almost 8,000 documents started from 1913. People looking, okay, the technical thinking, the mathematical thinking as a tool to solve a problem. Okay, nowadays during COVID-19, all right, people use the way how to, and let's we do the mathematical thinking at Scopus from 1970. Okay, almost 7,000 documents. Okay, especially for 2020, 2019, 2000. To handle their research and to communicate with the industry, right? So now I love to use a few terms when you start think something, all right? So we call as a method of thinking. I know, okay, we always ask students to understand, to give the properties some time to observe and share their experience with the student. We have a strong using and bring extracting information, especially Dr. Noraini, you are from computer science, you know how to recall information from memory, all right? And stretching, counting by using mind.
Scratching, huh? Counting.
Okay, for something, okay, from ideas and knowledge, okay, describing, do a visualization, and create the algorithm or procedure, all right, for pioneer beginning to the end of your
Process.
knowledge, right?
Yep.
So now, okay, you also abstracting, okay, differentiate and equate, classify, category, and then how to prove using positive on contradiction. Okay, you find the argument, you find the reason, okay, for something problem, all right? You expand the discussion and do the opposite statement when you have a statement, all right?
Mm-hmm.
This is the way how you are thinking for
Yep.
something, right?
Mm-hmm.
As per structuring the argument and give a new perspective and create a theory, right? How to
Yeah.
create a theory when we want to deal with the mathematical thinking? Maybe Dr. Naraini want to ask me a question?
Yes, actually, from the method of thinking just now, you list out the 23 methods, okay, which actually the specific elements of the mathematical thinking.
Yes, okay.
Mm.
There are so many, 23. Now, let's be structured. Let we organize. Let we train our mind, all right? Actually, I do some workshop with the teachers and lecturers about the mathematical thinking, okay, in 2022, all right? So now we can conclude from Prof. Abu Osman and Dr. Ali Noor 2021, okay, they create 9 elements of mathematical thinking. There are so many elements, but they try to organize it as read, means that read the literacy. Okay, read. All right, find the words. Okay, this is a I think school level first year student. Okay, we ask them to understand the concept, recall and do a reflection, join together all the knowledge and find the integration and expand, okay, the formulation, all right, the theory, okay, to a new, okay, a new style, understanding, and do a generalization. So the question here is a generalization and specification because they want to answer a question and then they want to find a solution. All right. So we explain them 8 steps. The last is a stretching diagram. Why? Because the ideas can be structured, can be visualized, can be descriptive, right? So that is a 9 element. So now we go to the school, okay, primary school, for example. How to apply this 9 element, all right? You can see here, we want to find mode, median, okay, range, all right, for a specific data. So in this case, okay, we need to generalize a group of data and make inference, meaning that, okay, if we change the data, the style of concept, okay, the style of the generalization, the knowledge is similar, all right? And the other question, we can recognizing their central element. For example, if I change the data to a new data, so students have a good mathematical thinking, they know how to read, they know how to get keywords, they understand the concept, okay, they recall and do the reflection towards the end, they still remember the formulation, okay, the basic formulation or generalization, and they know how to solve what we call very specific question, meaning that challenge question, grand challenge application. And next is structured the idea in stretching the diagram, drawing the diagram, right? However, when we go to the university level, mathematical thinking at the university level, okay, Prof. Tahir 2021 proposed 10 elements for the mathematical thinking at university level. The first is, since we are mathematicians, so we know the history of mathematics. Second is a brief of the equivalence element, meaning that how to formulate, all right, how to develop a formulation based on the axiomatic system. Okay, these are algebraic and geometry ideas and knowledge should be bring up, all right, and how to communicate with the student, with our customer, with the industry. Okay, we need to use a notation. Okay, this notation will help us to understand the new knowledge, all right, and bring the classical set theory and logic, because to create the ideas, we need to have the start from the set theory. For example, fuzzy. People always say that fuzzy set, okay, fuzzy logic. So we start with the Zadeh. Okay, they explain that there are so many solutions when we have a data. The set of solution can be many, okay, types. The graph, okay, we call as a fuzzy, right? So there are so many arguments, okay, to represent the new knowledge using set theory and logic. And then next is a proof. In mathematics, okay, without proving, okay, the argument cannot be accepted much, because the way how to prove, okay, I just explained just now, contradict, okay, deduction, intuition. There are so many ways to do proving for the new knowledge, right? And then the next, okay, the 4 element here, okay, is more deep, because we want to categorize, okay, the knowledge. Okay, the people who are comes is from category 1 or category 2. All right, category 2 meaning that they are using all the element 1 to 6. Right. So this is what we.
Sorry to interrupt you just now. The graph is not a graph, but the number 1 until 10, which the yellow coded is for the school. At least school managed to have that cycles, and up to 7 to 10 is basically after school, which is university level. Am I right?
School is a 9 element. Read, keywords, understand concept, till stretch the diagram. But for the university level, okay, because we want to publish in Q1, we want to publish in good journal, okay, when we want to express a new knowledge, we want to introduce a new knowledge, a new theorem, a new theory, a new formulation, a new axiom, a new postulate, a new colorist, we need to follow, okay, number 1 to number 6, okay, where we start brief, okay, the ideas in the mathematics, we do the excluded element, okay, we prove using the arithmetic system, all right, we express the formulation using the mathematical notation yang cacing-cacing pula kan, and then okay, we explain, okay, a new phenomena, for example fuzzy, okay, in my case fuzzy, I'm using the set theory, all right, and the next is this is considered as okay, category, a good category, high category mathematician because they go through, okay, they're explaining knowledge using all these points, right?
All right, got it. Yeah.
Okay, all right. So this is transition between the school and university level, all right? So the universities or first year student, they need this knowledge, right? So now I explain the example. Example, very simple example, all right, theorem Pythagoras. Everybody know theorem Pythagoras. The great philosopher Pythagoras, born 570 before century, okay, create the fundamental relation in Euclidean geometry about the about the theorem Pythagoras. He said that, okay, for every, okay, angle of the triangle here, okay, A squared plus B squared equal to C squared. The summation area of the two squared of the legs, meaning that A and B equal the area of the square on the hypotenuse. All right. So this is the formulation from the Pythagoras, said that A squared plus B squared equal to C squared. Okay. If the degree here is a 90 degrees, all right? So this formula is it can be generalization for the law of cos, law of, okay, solid geometry, non-Euclidean geometry, and differential geometry. So this is considered as a generalization of theorem Pythagoras. Okay, let's we go to the example here. Okay, we know that when we put the number 3, 4, 5, 5, 12, 13, 6, 8, 10, 7, 24, 25, 9, 12, 15, okay, when we apply to this equation, we can solve, okay, for the missing side of triangle because we following this, okay, sequence number. But, okay, how to prove it, okay, we need a statement at the series of the logical step. So that's why I said mathematical thinking is you're confident to express step by step a knowledge, right? So I put some example here, okay. In the diagram, okay, we want to find, okay, we want to find ST, okay, ST is here, right? So how to find ST? So we are going to use theorem Pythagoras because, okay, we know that PQ is equal to what the value that we have, 10 squared minus 8 squared, all right? And then after we know PQ, we know what is a PS, okay? PS is equal to, okay, they are giving us 15, okay, minus 12 squared. So it's a 9 centimeter. So ST is very easy, just a difference between the long length and the short length. So this is what we call as a concept, we understanding about the theorem Pythagoras, right? So now there are so many examples here, okay? So the step that we need to show here is in the sequence, in the step by step, right? For example, we want to find the square of the TSPU, we want to find the parameter, the whole diagram, all right? So all is depend on the area, okay, the square, okay, the area of the triangle. And then next we apply again the theorem Pythagoras because we believe that theorem Pythagoras is available to find the angle, right? and then plus the angle, we can find the parameters. So the process that we highlight here is a really structured, step by step. All right. So now I know, okay, since we always deal with the data, all right. So I put one example of mathematical thinking to prove the fundamental statistic statement. The fundamental statistic statement here, I just want to show that, okay, the equation is always zero, right? When we have a data, okay, S1, S2, S3, S4, up to Sn. So when we do a summation of deviation from the average, we can get summation Si minus S bar. S bar is a average. So how is the average calculated? All right. So we know already based on the concept, the average is a summation Si divided by N. N is a number of data. Okay. So now we can do manipulation to the original equation where summation X minus S bar is average, is equal to summation Si minus NS bar. All right. So I'm using the notation here, okay, to represent, okay, the summation of X bar is equal to NS bar. All right. And then substitute in our expanded version. So it depends on the people. If you are expert in statistics, okay, you know how to represent, okay, the notation, but you are not expert in statistics, but you also not familiar with the notation, okay, you can express in words, okay, summation Si minus NS bar equal to summation Si minus N 1 over N summation Si, where I divide all the equation left and right depends on N, okay, divided by N. So from here, okay, I can see that I can show that the equation is equal to zero, okay, from left and right. Okay, so I put summation Si minus summation Si is always zero. So now I'm using the words manipulation. I'm using the words, okay, divisions of the average. I'm using the words expanded version, all right, expand, all right. So this is the words that we are want to highlight when we explaining not new knowledge or knowledge to the people. So in engineering, I also believe there is another thinking we call as a computational thinking to support your ideas. Okay, what is that? Because the computational thinking can identifying a clear, defined step-by-step solution to a complex problem. Computational thinking have a few steps, have a 4 steps. First, decompose. Okay, decompose means that you need to map, you need to partition, all right, the data, for example, and then pattern, you do a pattern, okay, pattern meaning that the structure can be patterned, and then you do the abstraction, okay, how the ideas is not clear, you make an abstraction, maybe you need a theory, Colliers formula, all right, and develop the algorithm thinking. This is what we call step lah, step 1, step 2, and then you back to step 2 again. So there is a procedure. This is the algorithm. Okay, this is algorithmy to support the thinking. But in mathematical thinking, you know that I explained very clear here. Okay, you perform step by step and increase your confidence level by using the few step forwards. Okay, maybe you support with the axiom, maybe support with the theorem and others. And that will involve in 5 process. Representation, and then there is a reason when you do a proven, okay, and then do communication, problem solving, and connection. Connection just now is integrated between the knowledge, right? Because if there is no integrated, you cannot get the outcome. All right. So now, what is the outcome when you do the interaction between mathematical thinking, computational thinking, and programming? Because you always deal with this phenomena because you are from engineering education, all right? So what is the output? The output is a mathematical task, is a program, is a coding, all right? Is proven, is a prediction, is an observation, is a monitoring process. All right. So the product is maybe program, all right, simulation software, all right, courseware, and this courseware should be validate. So now how to do the interaction? So now we have a problem, okay, we call it as a mathematical task, all right? And then we start thinking how to solve this problem, the problem solving process, okay, justify for the solution and mathematical skill to solve the problem. For example, you use equation, you use a data, you use fuzzy, you use modeling, you use numerical, so you're using differential equation, PDE, finite difference. So there are so many tools to highlight by using a mathematical thinking. Next is a computational thinking. Since you have a strong argument, okay, strong theory, Colliers, axiom, all right, you have a strong background of mathematics, okay, you start solve this problem using the logical reasoning, okay, algorithm thinking, decomposition, generalization, abstraction, and evaluation. So this is a process dealing with the numerical, maybe dealing with the computational cost, dealing with the platform, all right, dealing with the high performance computing, for example. Okay, so the computing thinking is more on the, okay, how you abstract and how you do the evaluation or performance evaluation, all right? So now the process that required you to develop algorithm, all right? Maybe you are using algorithmy, you are using procedure, all right? And then next you transform the procedure into coding. So maybe you are using C++, Fortran, engineering, I think Fortran, all right? Maybe Visual Basic, maybe you're using Mathematica, MATLAB, Console Multiphysics as a courseware to support your solution. And next is a coding testing. If you deal with the big data analytics, you need to do the testing, okay, and validate, okay, your solution. All right. So now I'm using this style of thinking, okay, during the COVID-19 last time, okay. We want to investigate, okay, how the potential of students in engineering using some numerical methods, okay, for understanding some concept in numerical analysis, right? So now, okay, based on the result, okay, I'm solving using Amos, okay. Okay, accessibility and reliability of the software will give a good impact to the satisfactions of the software for students. All right, so it's come from the performance improvement. We look at the performance improvement. Okay, we know that, okay, the satisfaction, the impact, the influence from the software easy to access. Okay, the software is a real, okay, and easy to use. So this is one important or high indicator to get the perception of student for the specific software, right? So I'm using MATLAB here. I'm using Mathematica. So as a two software that they are familiar with, all right? And then they said that MATLAB is better because easy to access and real, okay? And very high reliability. All right, so now I just want to show here, all right, how the mathematical thinking, especially problem solving, develop a model, do a data analysis, all right, and applying the arithmetics, algebra, calculus, okay, and accounting, that will create you attitude. Okay, what is attitude? Positive thinking, all right, positive thinking, because this element support the you when you do the optimization, right? So in this case, okay, we hope student, okay, open mind to expose themselves with the new knowledge. Okay, I'm using one survey, okay, I'm using this survey to the student, but the student still not aware about the big data, about the data analytics, okay, about the data leakage, okay, about the how to protect a data and others. So meaning that student should be exposed, okay, a new knowledge, because from the new knowledge they know how to do the mathematical thinking to explain this knowledge, right? So now, since my area is data analyst, okay, so you can see the journey, okay, the journey about the creating a new knowledge. until we make a decision. Okay, what is the journey? Okay, when we have a data, right? Okay, the logic thinking, okay, we need to reduce the noise from the data, right? We do a data transformations and we explore the data, right? The next is we apply the statistics methodology, okay, because the fundamental to analyze the data is a theory of statistics, right? We based on this theory, we do the data cleaning, okay, data properties, okay, preparation and data analysis, right? The next is okay, we do more detail when we have a final result. So this one is explore or extend more specification. All right, we start applying deep learning or bring the statement of the art of the solution. All right, and then we also apply a few methods. We compare between convolutional neural network support vector machine, extreme learning, genetic algorithm, and others. Okay, based on the comparison, we can do evaluation, we can do analysis, all right? And the next is because we deal with the competing thinking, because we deal with the software, all right? So we do the collaboration, we do the communication between the data, okay, and then operation professional to manage the um, the lives, okay, the life cycle of the data, all right? So this we call as a data analytic because the data always generate based on the velocity, based on the volume, based on the structured, unstructured data. So this is a process that we maintain, okay, to get a good result, right? So now,
Uma,
yeah,
what's in your opinion actually? How
mm,
actually we can embed the
mm,
mathematical thinkings so that our online teaching and learning tool can be utilized, especially for engineering education. We can utilize the available tools, online teaching and learning tools, to express or to embed or to utilize this to apply this mathematical thinking.
okay. Okay, I just want to share my Padlet. Okay, I have a student doing research with me. All right, all the research deal with the mathematical modeling, simulation, okay, data analytics and
Okay.
others. So I plan. I'm using Padlet. I plan the way how they need to achieve. I know this is a schedule, but actually I plan them. Okay, which part they need to start highlight the research methodology by using AMOS research methodology, you know, by using AMOS, by using the 100 literature review. And then next, okay, they need to highlight the model that they want to represent, okay, or they want to focus for chapter 3, all right, and chapter 4, all right. And then next is what is the next is they need to prove, they need to prove the ideas and concept that they want to use, for example, enhancing the fixed floor, for example, okay, modifying the balance or the what we call controllability parameters. So I need to put in the step by step. Okay, this is, I think, step by step structured to make sure towards the ends of this Padlet is completing chapter 6. Okay, after do the performance evaluation and others. So this is very important actually because we are online. Okay, student not meet us, especially COVID-19 pandemic. All right. So Alhamdulillah, okay, they finish their masters, their PhD. All right, because I plan them, they need to follow. Okay, they need to follow the step or the thinking that I think can help them to complete their masters. So now the attitude is very important, all right. And then the next is attract student interest in teaching in engineering education or in STEM, all right? Because based on this Mentimeter, we know that blended mathematics. You can see here blended mathematics cross pollinating, computing, collaboration is very important when you deal with the education mathematics. and engineering education by using the mathematical thinking. We know technology is one of our aims. We cannot run from the fourth industrial revolution. So that's why we track the student for their future, what they want to be, whether data scientists, data engineers, information sharing, ICT services, software developer, all right, visualization, presentation, animation. So there are so many, there are so many job spec, when we deal with when we deal with the industrial revolution 5.0, 4.0. So we need this, we need this skill, For example, the users must know for example, Google, WhatsApp, Facebook, all the social media, all the skill of the education 4.0 software and hardware, and what the impact to the student to create the track for 4.0 industrial revolution and job scope, right? So I know, I know my student engage with the multidisciplinary field. For example, in AI, in visualization, in data mining, in statistics, pattern recognition, right? If they deal with the nanotechnology, and all integrated, with a good communication and problem solving. So to engage with these complex phenomena, how I train my student, using the mathematical thinking, to decompose, to partition when we have a messy data, multiple set data, very large scale of data, dynamic, heterogeneous data stream generated with high speed, high speed velocity and others. So how we can put, the decomposed data in fully trust, quality and accurate for the data constellation, right? So this is very important because mathematical thinking or statistical thinking create them to work hard, all right? So you look here, this is the early part of roadmap with the fundamental mathematics and theoretical statistics to produce, my student as a data scientist and data analyst, all right? So they need to go to this all journey, all right? First is a strong mathematics. We are not school level, we are university level, so we need to have a strong mathematics. We hope that they can they create a mathematical thinking, with the 7 element and 10 element, all right, and theory of statistics, all right, and then do a programming. Next is how to handle a data, expert handle the data, all right, do a machine learning because we want to do the fuzzy, we want to do more AI, and then we skip because the data is big, so we deal with the deep learning, we do a data visualization, all right, we deal with the big data with a high velocity, high what we call, there are 7V, velocity, variety, all right, visibility. So we deal with the big data, and towards the end, because the data is always in cycle, in life cycle, in data cycle, so we improve the version, to get the good prediction, right? So I know, students start when the data is very huge. They cannot work with one CPU, one laptop. So in this case, we start introduce to the student another one, style of thinking we call is a computational thinking. That's why if the data huge, we need to use high performance computing platform, all right? So this is a skill, there is what we call extraordinary skill, 33%, all right, for hacking, 30% for mathematics and statistics knowledge, and 33% for the substantive expertise, right? So now, I'm always ask the student, let's we discuss what happened to Malaysia, because now still has COVID-19 COVID-19, pandemic. So what happened for endemic, is the influenza affected by COVID, or COVID affected by influenza, or what happened to the data for the next 3 months, right? So in this case, we start student to think, So there are so many solutions to create the forecast or to predict what happened to the country for the next 3 months. There are so many solutions. Some of them using modeling, some of them using statistics, some using AI. All right. So now let's we discuss. Okay, what is a pattern? Okay, that we can create from the data. Okay, of COVID-19. All right. So Dr. Nuraini, do you want to ask something?
Actually, I do ask just now the same, the similar question. Okay, how actually we can embed the elements of mathematical thinking in teaching and learning tools. Okay, so that
Well,
our especially engineering student, engineering education, engineering student, okay, can utilize the tools to apply the mathematical thinking in their case, any case, especially.
yeah, right. Okay, I already answer your question. Okay, we are using so many types of the education 4.0 software, but in this case, okay, when you deal with the engineering education, when they want to do a research, they are really serious, okay, in solving the grand challenge application engineers.
Yep.
So we need a tool, we need the
Yeah.
hardware, we need a
Yeah.
software. All right. So what the Adrian Douglas, CEO of the Neuro, said that, okay, understanding logic at the deep level has improved my problem solving, okay, efficiency. All right, meanings that, okay, they not just apply the tool, software and hardware, but they need to know, okay, the 10 element mathematical thinking at the university level. What is that? You need to know the history of the mathematics that you want to use. You need to prove using the axiom, postulate, geometry, set theories. All right. You need to explain using the mathematical notation where the people can understand easily. All right. And then applying skill in the disciplines such as human computer interaction, okay, user-centered design, okay, project management, software engineering in different stages of the software lifecycle. Okay, this is one of the effort, okay, when we deal with the mathematical thinking in engineering education, because they need a result fast. And learning the theory behind the software. Okay, this is really effort. Okay, hands-on experience, skill, knowledge development over the apparatists, because we are still apparatists, meaning that we are still in the journey to describe the new knowledge in the style of mathematical thinking. All right, understanding the emerging technology influence decision making and to push the boundaries of mathematical thinking when it's come to develop. Again, if we can collaborate with the pure mathematics to represent your ideas in theory, in theorem, corollaries, axiom, postulate, rules. Okay, it's very good, right? Learn how to be more innovative. Okay, for foster connection with the both industry, because you are part of the industry. Okay, you are deal with the mathematical thinking, all right, computational thinking and coding, okay, to create the innovation, right? So there are so many example here. Okay, uh, I just want to show here my mathematical thinking at this problem is, okay, create a theory of the fuzzy and then apply the theory when I have a big data from the electroechography EOG to to get the data from eyes muscle or eyes movement. All right. So based on the every second data generated, okay, I analyze using the neural network, because the data is very huge. When we convert from signal to digital, I need to use high performance computing. And then towards the end, I know that after 3 hours, the eyes of driver become weak because they are really focused for the specific point when they drive. All right. So now I'm also using mathematical thinking when I want to visualize the temperature behavior for the multi-layered full chip system. I don't know, okay, how the temperature look like, because, okay, it's very fine. I cannot find from my naked eye. So what should I do? I develop the mathematical modeling. All right. So to develop a mathematical modeling, I need to know the fundamental theory of the temperature, okay, of the pressure, of the density. All right. So in this case, I'm using the what we call Fick's law, okay, wave equation. I'm using Poisson equation to represent the wave, right? So this is the result that I can get. I can visual the temperature behavior in full chip system using the Poisson equation. I'm also don't know. I'm also don't know how to express, okay, some properties, okay, of the thermal conductivity. All right, when I deal with the nanomaterial, for example, nanosilicon, okay, metal, okay, I cannot okay, represent it in physical. So in this case, I'm also using the mathematical modeling and compare or validate with the data generated by sensor. All right. So now let's we go to our home. All right. There are so many Internet of Things. All right. Internet of Things data generated from sensor, especially when we want a good condition for safety, energy management, okay, maintenance, okay, in entertainment control, for example, in our home. So we deal with the sensor and then how to analyze this the data generated from sensor. So this is one of the point, okay, that we can highlight here using the mathematical thinking. All right. In this also, okay, we have so many, okay, element here, okay, sensors, device, Internet of Things, IoT, all right, cloud, okay. So all dealing with the mathematical thinking because they want mathematical thinking guide you to get a good product, right? And others is when you have a sensor of bio, okay, nano things, for example, you want to find, okay, how the molecular motor in your body, bacteria involved in your stomach, okay, calcium signal in the body, all right, the beat, the temperature behavior, the blood flow of your body. So all is deal with the sensor, collect data, and analyze the data. So of course, I'm agree with the, okay, some philosopher in mathematics that the next era is a data oriented. Okay, come from the many device, meters, sensors, okay, satellite, GIS, and others. So I'm also using GIS because, okay, we want to find the changes of the land, okay, because of the land chop, changing of the river, changing of the road, develop a new building. All right, so all can get from the GIS image processing. So okay, when we have image, we need to transform image to digital. From the digital, from the data, we can analyze. Right. So this is a what we call logic thinking. Okay, descriptive thinking, structured thinking, step by step thinking. Right. Because of this thinking, so Alhamdulillah for endemic era, okay, there are limited of the virus spread. Okay, in COVID-19, we can see from pandemic to endemic, okay, and epidemic. We can see that, okay, now in Singapore, in Malaysia, the number of people, okay, get virus, okay, reflects by virus, okay, death because of the virus is minimizing. All right. So now you always look at the movie, okay, 3D movie. It's not easy, okay, to move the 3D movie, okay. So this also deal with the mathematical thinking because they are integrated with the computing thinking. They are using very fast, okay, very fast high performance computing, all right, to support the huge calculation, right? So now, yes, Dr. Noraini.
Sorry, I unmute. Okay. So in your opinion, actually, uh, how we as a bring the importance of mathematical thinkings to be introduced, to be embed in our learners, how actually we as a educator can design the course structure, the course activity, okay, so that our students have these creative and innovations in applying or the ability to grab this mathematical thinking, at least
2, 3 out of 9 elements just now.
Mm-mm. Okay, Dr. Noraini, I know you already practice 23 method of thinking. Am I right? I know. Okay, whatever in your life, okay, at home with the children, with the student, okay, with the neighbors, you always practice 23 method of thinking. All right. So now I just want to address how to improve, okay, how to do the improvement, okay, of thinking. That's all right. I know all the lecturers are very good, okay, in mathematical thinking. Just tips to improve the mathematical thinking, okay. For example, here I said that, yes, okay, what Dr. Yudaria, okay, our expert in mathematical thinking, especially for problem solving, okay, they said that okay, some basic mathematical concept and notation, okay, should be go through with the proof techniques. All right. So meaning that this will be applied for anywhere. For example, okay, you have a research, okay. So now how you want to create, okay, how you want to bring this knowledge is a high contribution novelty, okay, in this era. So you need a proof. Okay, how to prove? So to prove you need the mathematical thinking. How to do with the mathematical thinking to do a proving? There are so many ways
Yeah.
to prove. All right. So now the next is a imitate pattern. Okay, why pattern? Because you understand about the thinking. You have okay, you identified the problem, right? You expose yourself with so many techniques, especially in engineering, all right, in computing thinking, all right, for in programming, in coding. So that's why I think this pattern, okay, will help to improve your mathematical thinking. And then practice, and
Yeah.
practice again. This is the biggest contribution to cultivation of the mathematical thinking. I know, okay, because we need the frequent study, frequent research, and others. And I'm not the good people to express the three philosophy, but I just want to share. Okay, the first, what Prabhu said, read, understand the keywords. It's like literacy, means that you can visual the complex environment. You can do the ability, okay, to create, to understand, to create, to communicate with the data. All right. The second is the competent, because you said just now we are online, all virtual. So we need to competent with the hardware, software, okay, network tool, cloud, AI, all right, working with the data and others. And then the third is ethical crossover. All right, what is the ethical? We try to harmonizing the engineering education. Right. So this is integrated between the intellectual aspect, for example, the roh, okay, kalbu, nafs, and akal, because we want to create a new knowledge and new ideas, right, with the wisdom and the choice of the intellectual. So I don't want to go more, but okay, I just want to go with the simple conclusion. Okay, what is my conclusion? I just said that mathematical thinking is a challenge, okay, based learning in engineering education, because you are already engaged with the so many applications. Now you want to go back, okay, back to the mathematical thinking to use all the element to do a proven of your new knowledge, all right? Mathematical thinking direction, okay, we know that the basic structure of engineering education was set in 1955, all right? And then there hasn't much, okay, changed. Rather than hands-on problem solving, classes emphasize theory and digital transformation. Now let's, okay, we do the good direction when you want to explain a new knowledge. All right. The rule of mathematical practitioner. Okay, what is that? Integrating with the data, solving a grand challenge application, perform architecture platform for the better performance, better decision making, better forecast of your problem. All right. Since when we said that, okay, we try mathematical thinking to solve a complex model. What's that? Okay, we know that we deal with the dynamic solution, static, okay, time dependent, independent. All right, we deal with the discretized, we deal with the digital strategies in engineering education. So what should we do? Okay, redesign engineering education curriculum based on the mathematical thinking, innovation, new area of the knowledge and AI technology. Because now people deal with the technology, deal with the sensors and others, right? All right, so now let's we integrate mathematical thinking, computational thinking, programming, coding tool into the engineering education, and we hope that there is a research collaboration to leverage your future initiative, right? So the next is we hope we can harmonizing the engineering education 4.0 and 5.0. All right, so that's my conclusion, Dr. Nuraini. I just want to wish thank you very much.
Okay, Dr. Noma, I think that's the conclusion wrap up everything that means to summarize the very key points of our Sembang Santai today. Actually, it's not Sembang Santai. Okay, maybe quite heavy juga untuk beginner macam saya. Tetapi because of I think everyone in the world should unconsciously we apply the mathematical thinking in our day-to-day tasks in our environment. Okay, but we do not conscious that is actually the mathematical thinking procedure. Okay, to end our sembang santai today. Okay, I would like to uh, re-summarize again. Okay, so I am very interested in this in the definition of mathematical thinking just now, where actually if we have the ability of mathematical thinking, is actually it is our comfort, okay, that we can solve the problems in procedure, in step by step, by maintaining our confidence, right? Means we can validate our kepercayaan lah, sebab kita dah proof apa yang kita dah solve tu tadi. We can maintain the confidence by our validation, okay, and then we can generalize next further, okay, our confidence tu tadi, our validation to other abstraction, to other generalization in solving the new potential areas. Contohnya, when we have this incoming, not incoming lah, memang akan datang IR 4.0, IR 5.0 dengan IoT, sensors. So the data will come, okay, we confident to solve the problems in steps by steps, in procedure, okay, because we have this proof to solve the similar pattern, okay, because we have this ability of mathematical thinking together with computational thinking and also the creativity, innovation apa ni, application lah yang kita nak apply. Betul tak Dr. Norma? Yang saya dah faham hari ni, saya grab something which saya rasa sangat besar sebenarnya, definition mathematical thinking tu. Tanpa sedar, okay, without our conscious, sebenarnya kita memang ada dan kita mungkin tidak tidak disedari secara yakin lah yang kita ni sebenarnya day to day kita memang kita ada menjalankan, menggunakan ability kita, skills kita di dalam think with mathematics, ya. Okay, Alhamdulillah, saya rasa perkongsian yang sangat menarik untuk kita kongsikan bersama manfaat ini. Okay, pendedahan yang mungkin secara beginner daripada awal tadi kita pergi kita tengok, okay, sebenarnya apa itu mathematical thinking, apa elemen dia, okay, apa pula comparison. Sebab saya sangat berminat, saya datang daripada software engineering background, saya memang pasti dan realize memang ada pertindihan antara mathematical thinking dan juga computational thinking tadi. Bila Dr. Norma kaitkan dengan software engineering life cycle, now saya kata memang every life cycles of the products. So in my case, software is the product, is the end product yang kita akan hasilkan sebagai software. Okay, memang kita kena go through the mathematical validation tadi supaya produk yang kita hasilkan diyakini kualitinya untuk kita punya stakeholder, end user kita. So same goes with other engineering, okay, civil, mechanical, okay, contoh tadi smart home, lagi apa tadi kita tengok bio kan, biology punya devices, semuanya memang you need to have this ability, okay, to prove the mathematical validation. Okay, Alhamdulillah saya rasa sangat berfaedah. Okay, very fruitful kita punya discussion kita hari ini. Terima kasih Dr. Norma kerana meluangkan masa dengan audiens kita hari ini untuk berkongsi pengalaman, okay, pendedahan, you punya expert, okay, pengalaman yang luas di dalam bidang big data especially, okay, dengan kita punya audiens hari ini untuk bercakap tentang mathematical thinking practice especially dalam engineering education. Okey, terima kasih Dr. Norma. Semoga kita boleh berjumpa lagi di lain hari dengan topik yang mungkin lebih menarik. Okey, Assalamualaikum warahmatullahi wabarakatuh dan terima kasih.